Hello, welcome to Introduction to Machine Consciousness. The purpose of these videos is to demonstrate a model and a methodology we can use to develop an artificial intelligence. In lay terms, machine consciousness is often what is meant by the phrase artificial intelligence. There are many examples of conscious machines in science fiction. HAL 9000 is the most famous. C-3PO, R2-D2, the characters from Tron, K9 from Doctor Who, Commander Data of Star Trek, Tachicomas from Ghost in the Shell, and the software programs of the Matrix movies are all fictional machines that demonstrate sentience or consciousness. We use the term machine consciousness to distinguish from the ongoing academic and industrial efforts that use computation as the tool to perform substitute tasks of human reason, perception, and behavior. These computational analogs of human abilities are a kind of artificial intelligence, but they are not examples of machine consciousness. We are not concerned with what we could call the performative features of intelligence or ingenuity. Rather, we want to be able to construct a machine with awareness and a mind of its own. There are three core problem areas that we must understand to create a machine consciousness. The first problem is, what is consciousness and how does it work? We need to develop a theory that is useful and explanatory for our own conscious experience and can be used to produce a sentient computer system. The second problem is, how does consciousness happen in organisms, and does it reflect our theory? How do organisms demonstrate the features of consciousness? Can we look at the biological phenomena and see that they correspond to our abstract theory? Because if they do not, it means our theoretical approach is incorrect. Moreover, can we develop a basic model for how consciousness occurs separately from the physical and organic case? This is especially important, because if consciousness is fundamentally a product of organic and physical processes, then machine consciousness will be impossible. The third core problem is, how can we produce consciousness with a computational system using our theory and the model we develop from biology? If we can understand the general requirements for a conscious system, what are the specific problems of implementing one with a machine? How can we resolve programming and hardware-specific problems to bring our computers to life? To be able to write programs that will instantiate consciousness, we must have an abstract theory that explains the mechanism or functions that generate consciousness. Our approach must describe how the variety of conscious phenomena function and give us a path towards a computational approach. The most important of the phenomena we must understand are qualia. Qualia is the word we use to refer to the qualities of an experience. For instance, we experience light as being colored, such as white light. Or we experience molecules as being flavored, such as in a sour lemon. Or we experience feelings and emotions like dizziness or frustration. White, sour, and frustration are not physical phenomena. We know this because we can have dreams in which we experience frustration, sour, and white lights. What is even more curious is that we experience qualia through art. Art's power is exactly the ability to generate qualitative experience through a representational medium. Language is a great example of this. When we read a novel, we can easily experience frustration of the characters and imagine a white light or the sourness of lemons. But words on a page are not themselves frustration, white, or sour. They are blotches of ink. When we look at a painting, we can identify a lemon in the painting. Similarly, we use mathematics and physics to describe how phenomena behave. But we know that physical objects do not carry around numbers or abstract symbols and values that regulate their behavior. These problems of aesthetics, knowledge, and mind are essential problems in philosophy. We all have philosophical ideas about what a mind is and how it functions, and about the nature of knowledge and experience. The trouble is that our ideas about minds and consciousness have not provided the functional utility necessary to produce sentient machines. Otherwise, we would already be living in a world full of R2-D2s and talking software personalities. So like Descartes, we will go back to first principles and see if we can develop a philosophical theory with functional power. As our goal is machine consciousness, the theory must provide a pathway to produce machines with minds. When we reach the stage of writing programs, we cannot be guessing about what consciousness is or how it functions. We cannot be having a philosophical debate about which conscious phenomena are important or useful that we can capture in software. We cannot have a system that is good at playing chess, but is incapable of having a conversation or making a painting. We must have a working theory and functional description that explains what our programs are supposed to do. It would be better to have a system that can play chess, paint, and have conversations, and do all of these things poorly, than to do any one of them correctly and be incapable of doing anything else. When we try to write programs without understanding the constraints and requirements, we naturally begin to modify the problem space to comport to our programming abilities and computational resources. All the historic efforts at a general artificial intelligence demonstrate this tendency. They each abandon the deeper philosophical issues in favor of specific examples of human action that can be accomplished with a computer. Sometimes it is hoped that by solving a more limited case of cognitive behavior, the solution to the deeper problem of consciousness and mind would reveal itself. This approach has not worked because the requirements for developing machine consciousness are not the same as developing software to perform particular kinds of human tasks, such as win at chess or Jeopardy or recognize faces. A solid theoretical foundation is necessary before moving on to writing software. Otherwise, we can only attempt to solve the problems we can imagine solutions for in the moment. A theoretical foundation is also necessary to understand how consciousness occurs in organisms. There should be no theoretical difference between how organisms are conscious and how a computer can be conscious. If there is such a difference, then we must assume the theory is not explanatory for consciousness, or we must show that what produces consciousness is a physical or organic feature, which makes machine consciousness via computation impossible. We and other animals manifest consciousness. It has been well demonstrated that our brains and neurological structures instantiate an awareness of the varieties of experience, like memories, actions, feelings, sensations, perceptions, and language. We know that if we damage brain structures or disrupt the molecular functioning of neurons, we block, disrupt, or alter our conscious experience. Using hallucinogens and other mind-altering drugs can dramatically change our experiences and states of consciousness. The use of anesthetics can completely block consciousness itself and can end neurological functioning, causing death. How do molecules cause such dramatic effects to consciousness? This is a core question an explanatory framework must address. Drug-induced phenomena highlight the difference between organic functions and machine operations. A computational system is generally immune to different kinds of physical substances affecting the computational process. But that does not mean a computational consciousness should be unable to experience altered states of awareness. We should have some method to describe why organisms have altered states and disruptions of consciousness, and how those same events can be achieved in a software system. Because consciousness occurs in organisms, some characteristics of organisms are critical to manifesting it. One of these characteristics is embodiment. What is embodied and how embodiment is produced are important issues that must be addressed correctly to create machine consciousness. An outstanding problem in consciousness studies is the problem of bidirectional causation. That is, how do we have ideas which are non-physical that produce physical action, and how is it that physical phenomena become qualia and ideas? Organisms resolve this conundrum. We will exploit that organic model in our software development. Finally, what we develop from our functional philosophical theory, and how that theory is manifest in organisms, is a basic model that should apply universally. We will use this basic model to tackle the problem of machine consciousness directly. There are a handful of particular requirements necessary to produce conscious functionality in computers. These in turn require specific kinds of computational approaches. As we move through the foundational ideas, we will always be discussing how what we understand impacts our approaches to writing software and creating programs. At the end of this series of videos, we will follow one approach, relying upon the biologically derived basic model, with the intent of producing machine consciousness in a computer system. Today, we do not have conscious machines. At the end of these videos, we expect to show how consciousness can be instantiated with a computer system, and begin the code writing process to do it.